It's a little blurry, but I think you'll be able to get the sense of it. I don't write a lot of text on my slides. It's mostly just to focus attention. A little bit about me. Like, I work as a consultant. I focus on improving architecture and development efficiency of whole teams. And I work for companies ranging from startups to Fortune 500. My tools and libraries have been used by over 80,000 teams. And things like Sourcery were mentioned by Apple at State of the Union. And previously I led the New York Times for almost 6 years. And in May, I decided to take a break from full-time jobs, because even though I was consulting, I was also doing like a full-time gig. And I decided after, I don't know how many years, 17 years of doing full-time jobs, I'm like, okay, I'm gonna take it easy. And so I started to work only on consulting gigs, and I work on my own stuff. And it just happens to be, I do enjoy programming quite a lot. So what I worked on is a lot of different apps and a lot of different ideas. And the thing that I noticed is I actually want all my apps to be done very similar. At least the base concepts, base tools, base frameworks that I use are always the same. And it's the same with the clients that hire me. I always recommend using the kind of similar solutions, regardless of what kind of product you're building, regardless of what architecture is it following. Is it TCA? Is it standard Swift UI? It's MVVM? Doesn't really matter. So in this talk, I'm going to talk about a project template. It's actually something I'm also building as an indie thing. I'm building a video course that takes 2 to 4 hours. I'm still working on the content. I was going to launch it this week actually, but I got sick last week, so couldn't finish it. We only have around 30 minutes that I want to spend on covering this, so it's going to be very dense. There will be a lot of tools, a lot of opinions, my opinions. You don't have to agree. Some of the tools that you'll see you probably heard of, you probably use because they are industry standard. And I'm going to mention some of the practices and reasoning behind them. So let's get over it. The first thing I want to talk about is how do you organize your projects? And there are so many options. The basic ones are CocoaPods, Carthage, or SPM. I think that in general today, I recommend using SPM whenever possible, mostly because it's the default that Apple gives us. It's very easy. And what I really like about it is forces you to modularize your application. And my recommendation is to have as much modularization as possible, meaning I don't really want to see files in PBX project file. I don't want files there, because every time I add files there and I have a merge conflict, I have to deal with the stupid UEIDs that are generated automatically. I have no idea what those numbers mean. They're messy, they're unnecessary. So what I do is I create a module called app feature, and I import that module into my main target, and that's the only thing I start, and everything else lives in SPM definitions. The other thing that I really like is, because you're forced to create modules, you have stronger boundaries. So you're also forced to define your public versus private interface, which is something that a lot of people don't do if they don't have separate module definitions. And the problem with that is if you do any kind of testing, any kind of sharing of the code with other people, it's really unclear if everything is the same access level, which are the methods or variables you should be accessing. It's not clear. It should be clear. You should be the one defining what it means to do. The other thing is, when you define modules in SPM, it makes Swift previews work much better. They're still not, I would say they're still far from perfect, but they're much more reliable if you use proper modularization. And I really don't like, before SPM and with Carthage and CocoaPods, some people organize code by placing files into roles. So like all the view models together, all the view together, all the controllers together. And that is just not very efficient way of thinking about it, because if you think about how you change code, it's usually you have to touch all different roles at the same time, because if I'm changing the view definition, I probably have to expose something in the view model, I probably have to expose something in the model or the controller. So that kind of organization never really made sense. SPM kind of forbids that because of the module organization. The one thing that I realized a lot of people don't do for some reason is they forget that package.swift is normal Swift. It's sandbox, so you cannot do everything. You cannot read files from outside, but you can add a lot of extensions. So what I don't like is some of the definitions in package.swift are just too verbose. Like if you have standard targets, you will have the target and the dependencies together, often the same names and stuff like that. So you can easily add extensions. You can add extensions for the common dependencies. You can even automate in loops. So if you have multiple platforms, you can decide, okay, this platform depends on this core frameworks and this platform on a different set, and automatically inject it into every target you're building for that platform. So there's a lot of conveniences you can build pretty easily, and I encourage you to do so. Now we move into build tools. So there are really three main build tools that most of us use daily, which is SwiftLean by JP Similar. Probably everyone here used it. Swift Format by Nick Lockwood, which is also a very standard. And the reason I like using those tools, and I really don't work on projects that don't, is because if I'm doing a pull request and I'm asking you for a code review, the last thing I want to hear from you is like, oh, this doesn't follow our code style. Like that is a waste of your time and my time. If there is a code style that we should be following, it should be fully automated. It really doesn't matter to me if the spaces are here or here. I truly couldn't care less. Just make it automatic. What I want from reviews is focus on architecture and focus on the higher picture, like higher level picture. What are the problems I'm missing? What are the cases I didn't cover? This is what we should focus on. That's where linters come in. And Sourcery, obviously, I wrote it, but I just think doing the same thing over and over again and expecting different results just makes no sense to me, which is why you should automate boilerplate. Now, again, most people use defaults. That is why when we create applications, we try to find the great defaults for our applications. Because if you have analytics in your products, you will notice that people rarely change the default. Like 80% of people probably stay on whatever we chose as the creators. The same with SwiftLint. SwiftLint offers you to create custom rules. A lot of projects I worked on didn't create custom rules. They just used, maybe they had like 1 or 2. I have projects that have over 30. And the reason for that is, again, if there is something that has to repeat in PRs and in pull requests as a comment, oh, we don't do this, or this is not the way to do it, there should be a way to automate it. And SwiftLint actually works really well. Here's an example of 2 rules. One is we use custom asserts in most of my projects because I want to be able to simulate assertion passing, because in production, asserts are not actually executed, so I want to handle the release case. And not every company wants to run tests on release. That's a different argument to be had. And the other rule that I often use is when I use TCA, there is a publisher on the view store, which is how you get notified about changes. And a lot of engineers forget that that publisher internally already removed duplicates. So they tend to add remove duplicate, and that's just performance costs with no added benefit. And so definitely write custom rules. The same with Sourcery. Sourcery will shine when you create templates for your project rather than just using the default. And so basically with Sourcery, I see my slide didn't appear correctly, so I need to fix it later. With Sourcery, like one of the standard usages that macros don't offer is ability to discover types in your whole project, especially if you use something like SPM and you have a lot of different targets. Companies like Airbnb and bigger code bases will look for classes or structures implementing a specific protocol and automatically register them in the main target. That is something you cannot do with macros because of the way macros are using visitor pattern. And this is where Sourcery is really useful, but also like just writing custom templates just to deal, even if you have like enum with associated values and you want to have a UI to, like, let's say you have enum for filters. Each filter has its own metadata. You cannot list it automatically using case iterable, but if you use Sourcery, you can generate a kind enum, which is just the names without the associated values, and then you can easily create UI. So that's very convenient to do. The other thing is when you integrate those build tools, a lot of people integrate it as either like a build phase, especially for Sourcery that was very often, or like a script. I think that the best way to integrate is as a pre-commit. And when you set up pre-commit, you also have a separate script you can run manually if you want to execute those tools without creating a specific commit. And the reason for that is it does add up quite a lot. Like I build a project between 200 and 400 times per day. On average, I actually tracked it. And 90% of the time, I don't need to execute those tools. I don't really care about the exact formatting. I don't care about Sourcery because it only affects a couple of types. And if you have a lot of engineers, let's say at the times we had 30 engineers working on the code base, the lower limit, assuming they do like 200 iterations, that's like 9 hours of time wasted just executing those tools. and they will execute on incremental builds. So even though Apple optimized your incremental build speed, it will add seconds to each of them. So that's not very convenient. I have a whole article where I go into details with math and the actual scripts you can use. You can find it on this link. This will be available later as well. Another section that I want to talk about is bugs and debugging. So how do we deal with issues that arise as we develop application, imperfections? We know how designers love pixel perfect designs and everything should be accurate. Not that it ever is, but let's try to get there as close as possible. So there are 4 sections, which is the bug reporting itself, avoiding stuff like memory leaks, creating settings so that you can easily control the behavior of your application. So like, for example, if you are testing something, you don't want to create an account each time because you'll create hundreds of accounts. So being able to simulate fake authorization, and then pixel perfection and the stuff around that. So first off, my favorite tool for bug reporting are there's 2, which is Instabug and Sentry. Both of them are pretty similar. Instabug is annoying because they don't want to support Catalyst. So if you want to use Catalyst as a target, Instabug doesn't actually work. But what you can do is you can use Sentry, for example, and you can just create your own UI and Swift UI as a way to report issues, pretty convenient. But Instabug has also ability to report, ask for enhancements. And the reason for providing this to every project that I work on, like every user that uses my projects, is because I want to avoid bad word of mouth. I have stories for that. Like I work at the browser company, and there's a tweet a lady wrote about performance in the browser, and that tweet had over 500,000 displays impressions in like 3 days. Not a good way to market your product, right? So you want to avoid that. You want to make sure that the users have ability to vent, and also you have the contact with the users, and you get additional feedback so that you can understand why specific problems happen. Obviously, you should be tracking a lot of metadata, but being able to contact the user is very convenient. Another thing that's very common is memory leaks. This doesn't happen in Swift UI. Well, actually it does, which is kind of interesting because when I added tracking to TCA, to tracking the view stores, I know how people are familiar with TCA, but basically I added to the observed objects that my views had. I found so many leaks in Swift UI that you don't even want to hear about it. Like there are modifiers that if you add them to your Swift UI, the whole hierarchy leaks. Not very pretty. Hopefully they fix it. Well, it's Apple, so hopefully is the keyword here. LifetimeTracker uses a very simple idea. This is an open source project that I released many years ago. It's one of the more popular projects I have. And the public version uses simply a counter. So for most applications, you can define how many instances of a given type can exist at any given moment, like the maximum number. So let's say I'm building like an Instagram application, and looking at how Instagram UI works, I can say that my profile should only exist 1 time at the most. Other user profile, probably similar, there are exceptions. But for most applications, I can say, okay, there's up to like 3. For example, at the Times, the articles are web views. So I know that we have some pre-caching and the maximum number was 3 web views. So I can decide that, okay, article view controller can only exist in 3 instances. The moment I have 4, there's only one reason for that. That's that one of the previous one has leaked, right? So rather than dealing with problems after your user reports it or you see crash in the App Store because memory ran out, things like web views tend to take a lot of memory. Rather than doing that, be preemptive about it, right? So with the LifetimeTracker, you simply define your numbers, and as you develop your application, the UI will pop up in your face and you'll see that there was a memory leak. And so you can easily find smaller diffs to find your issues, because even the tools that Apple give you, like the memory graph debugger, they're convenient. They don't work very well with closures. Like they're fine for object strong references. Like if you hold a delegate strongly, you'll be able to track that down. With closures, not so much. So what you really want to do is you want to minimize the code changes from the last time you tried it to the time you found the bug, because then the bisect for you to find the actual problem is much smaller, so you can fix it much easier. I build, so this idea is really cool, but you can extend it quite easily. For a lot of clients, what I do is I build a version of LifetimeTracker that knows about the data models in the application. For example, at the browser company, The LifetimeTracker has an engine that it still has number definitions, but they're more complex than just max number. They're like max per window, max per user profile, stuff like that. And then it gets fed the sidebar of the user, so which is all the bookmarks that people can browse on the web. And then that runs against those rules, and it matches up with data. So if you already use LifetimeTracker, adding the ability to read your project data makes it even more powerful. You can then bind your logic to the specific layout of your data, which is very, very powerful. Another thing that I really like is being able to control the environment I'm running my application in, especially for QA and for developers themselves. I want to be able to easily add things like, okay, I want to slow down this animation, or I want to tweak the curve of this animation. I want to make myself unmetered. So if I have a paywall, like at the Times, we had a paywall, you could read 5 articles before you had to log in or subscribe. With beta settings, I can just turn that off, or I can ramp up that number to 100. So when I test, it's very easy for me. I don't need to go and log in. I don't need to deal with all this stuff. Now this, pretty much all bigger applications have this kind of feature, but most of those applications write this feature by hand. So you write all of the UI and deal with like how do you map to the data and stuff like that. That's not very convenient. What you see on the screen on the left is all the code that an engineer has to write to have the UI on the right. So the way this works is Sourcery reads the data and generates all the Swift UI bindings for that data. And I use this in a lot of projects. When I introduced that at the Times, it removed 5,000 lines of code from custom UI. And it made it so that when the product people wanted to expose extra control, it took 5 seconds rather than 2 hours to implement it, because there's no testing that you needed to do because it's fully automated. It's the same tests also automated, covered by the previous implementation. And now you just define the data. And it supports structured data as well, so you can create substructures, substreams just by defining the Swift controls. Pretty convenient, extremely powerful, I would say. And I use this variant, like this idea of data-driven UI a lot. So this is, again, open source. You can use it as a base for your own implementation. I use this for feature flags at the browser. This generate, I think, 15,000 lines of code for custom feature flag controls. It generates all the UI for feature flags with the overrides, with extra debugging functionality. So it's really, really powerful. Now, macros will be able to do something like this to a point. Macros have the visitor pattern, so they cannot deal with extensions. If you define your data, if you define your object and then you do an extension on that object, your macro will only apply to the original definition. So it kind of forces you to a specific way of writing code, whereas Sourcery knows all of the AST. It combines all of the AST in your project, so it has more of a source of truth than macros do. So there are people that are adopting, like I merged, I think yesterday I have this project called Awesome Macros, which is just a collection of all the different macros communities building. And I think yesterday or 2 days ago, someone submitted a PR. They're working on something like this. It's called Prototype, I think. And it does similar thing where you can use data structure and it will generate UI to modify it. So kind of like back in Windows days, you had property grids. So this is the kind of the same similar idea. Another thing that I really like, this is actually a paid tool, but it's not very expensive. It's called Rocket Sim, and it's really cool because most of us work with the iOS simulator. Like I don't run my application on my iPhone most of the time. I only do it every now and then just to verify that performance is good and it works well in terms of UX. But most of the time I work on simulator because it's just faster and more convenient. So this supports a lot of extensions. So you can do stuff like invert colors, you can dynamically change type. You can do something as simple as you could do many years ago in older OSs, which is to simulate airplane mode without having to disconnect your whole Mac, which just drives me crazy. So network link conditioner that used to be popular. This does it for you for the simulator itself. It also has features like the Uber layer did, where you can basically use your Figma design and put that on top of your simulator. So that's also very nice. You can basically verify if you're pixel perfect or not. And the other thing it does for demos and stuff like that, it allows you to do screen recording from the simulator, but it has, other than what QuickTime does, it can add bezels of your device, so it actually makes it look much nicer. So this is very convenient. Antoine did this, and I think it's worth buying. Now the last thing, well, not really last thing, because testing is the last thing I'm going to talk about, but the thing that I care probably the most of is iteration speed. Iteration speed is basically the time it takes from me changing the code to being verify the results, right? I want that cycle to be as short as possible. And there are three main ways I do it in my projects. One is using stuff like Playbook, which is an idea that came from web, where you can launch a demo application, you can see all your screens in a single controller, single scrolling list, which you'll see in a second. The other is using preview apps, which means I don't need to recompile the whole project, but I have real stuff rather than fake data you have with Swift UI previews. And the last thing is something I've been a huge fan of for the last decade, which is hot reloading, which is pretty much standard on the web. Surprisingly, or not surprisingly, Apple forgets that exists. So let's start with iteration speed, right? The pre-fire playbook, there are two libraries, separate libraries, the same idea. What they do is they basically take all your views and place them in a container that you can see all the designs at once, which is very convenient if you want to send it to designers, or if you are doing major changes to some of the core. Let's say you're changing how the theming works in your application. I don't want to go and click through every single screen on my application because there are so many. So being able to just list everything, it's very convenient, right? So I can see all the different permutations. So not just the screens themselves, but also permutations. So for example, an authentication screen if I'm not logged in, an authentication screen if I'm logged in, if I have an error, all those things you can generate. They're very similar. The biggest difference is Prefire uses Sourcery and Swift UI previews. So if you already have Swift UI previews, Prefire will very easily grab them and generate this for you. With Playbook, it's a little more explicit. You create scenarios. Playbook seems more mature. Prefire is pretty new, but it also generates tests for you, snapshot tests using the 0.3 Swift snapshotting, which is kind of nice to be able to also get the tests, because the benefit of doing that is if I do a change and I send a PR, I will see the diff in GitHub, because GitHub will show you that the snapshot changed. So that's very convenient. SPM preview apps. So this is basically, you have your whole definition of your modules in SPM, each module, separate thing, and then you almost have no files in your project file, right? In your workspace, pretty much no files, but you create custom targets, and those targets usually have one file. That file, the only thing it does, imports your module that you want to work on and creates the fake data setup, or fake permutation of your data. Like, you can still use real clients and stuff like that, but you can set yourself up to be pre-logged in, stuff like that. So this is really convenient, because what this allows you to do is you can work on your module without having to recompile unrelated modules, right? Rather than running main application where you would have to count on Xcode caching being correct, which it rarely is, because Xcode has this wild idea that oftentimes I'm just gonna download all the packages, I'm just gonna recompile everything. I know where it gets it from. I think it should stop drinking so much, but this works very well, very reliable. I've been using this for a few years now, and so I highly recommend, if you're already using SPM, this is the way to do it, especially because you can create multiple variants and you can easily change it. You can even do stuff like, for example, what I often do is I create my view for that specific module, but I wrap it in a tab bar, and each item in a tab bar is a different permutation. So I can see the different permutations live and edit them. So that's very convenient. The last thing, and the most powerful, is hot reloading. So this is something I did, I think I started 10 years ago. I did Objective-C Playgrounds when Swift came out, because people were like, oh, they had to write this new language to do Playgrounds. It was not possible in Objective-C. I was sitting there like, I've been using this for 2 years. Like, there were two tools that did it. There was Dicey, which is dynamic code injection, and there was injection for Xcode. And it was possible forever. Even back in the very old days before iOS, Xcode had this edit and run button, which you could also do something similar. So 2 years ago, like after I did the Objective-C Playgrounds, that worked pretty well, but it required you to embed this big thing into your project. It wasn't very convenient. So 2 years ago, I open sourced something that I used with my clients, which is Inject, which is a very simple framework that is really cool because it's a no-op in production. So if you include it and you integrate it, you don't have to do any if-defs, you don't have to write any logic that is weird and funky. It's actually for Swift UI requires 2 lines per type. You simply add an injection observer and you do, at the end of your body definition, you do enable injection. And that's it. In production, that just disappears. It's just no-op, returns self. What this does, it basically allows you to both in Swift UI, UIKit, and AppKit, live code, right? So what Swift UI previews do with real data, and you don't have to prepare. So if I already have this integrated in my project, what I can do is basically, I'm working on my project, I see something that seems off, I open that file without closing my project, I save the changes, and the code and the whole view reloads. I don't have to even restart the project. I don't have to enable anything. It just works, just changes. Like here, it's a real project running, and just changing the text, changing the layout. This is also extremely useful if you're new to some API, if you want to play with new Swift UI like extensions that they added, because you can live code it. You don't have to restart. You don't have to do anything. And honestly, this works more reliable than Swift UI previews for majority of projects. It doesn't require modularization either. Like I still think you should modularize, but it doesn't require it. The way this works now, it even works with value types because it uses LLVM interop. So there's 2 settings you set up just for debug in your project, and it will redirect compilation to this injection for Xcode tool, which runs in your menu bar. It doesn't require you to unsandbox Xcode, do any crazy stuff. Like your app cannot run sandbox in debug to be able to do that, but that's pretty much it. It doesn't affect your release. Really powerful. I would highly recommend you try it out. The last section I want to talk about is something that's very dear to my heart, which is testing. Testing is popular in a lot of environments. For some reason, it's still not very popular on iOS. I think that's a mistake because I often hear that people don't want to do testing because it's not worth the effort, it doesn't add the necessary value. And I would argue that most of the time when I hear those arguments is because people didn't spend enough time to learn how to write proper tests. Because with proper testing, you actually are faster because you're able to simulate scenarios much quicker. Your run loop is even faster than with all those tools. Hot reloading is still faster, but with standard tools, it's much faster because my test suits run in like 0.1 second. So I just run it. And if you don't need hosting, especially, that's even faster. Even injection for Xcode supports hot reloading tests. I don't reuse it. I tend to have very, very short iteration cycles when testing. But what I argue about is a lot of the iOS applications are built in smaller teams, and there is a lot more benefit to doing tests if you have small team. Because if I have a large corporation that I'm working with, they usually have a dedicated QA team. It's not my responsibility to make sure I didn't break everything. Before the release happens, the QA has to verify that the project still works, I didn't mess up user data, stuff like that. If it's small team, it's on me. I have projects that have millions of users that I am the only engineer working on, and if I didn't have tests, I would be scared to do any updates. Like Sourcery itself, 50,000 applications using Sourcery, and I rewrote the parser from SourceKit to Swift syntax in a week because I had thousands of tests. If I didn't, I would be getting death threats at this point because there's so many changes, so many companies being affected. We're talking about massive impact on the industry. So having tests keeps me sane, especially as someone that does a lot of open source. It's just the only way to deal with this. So there are 3 things that I recommend everyone uses. First off is Swift snapshot testing, which is 0.3 replacement of Facebook snapshot tests, which were popular many years ago. What I like about this, they took some inspiration from Jest and some other web concepts where they allow you to do snapshot testing, not just on images. You can snapshot test data, you can even snapshot test database migration. So if you use GRDB, there is an extension you can use that verifies that your migration are actually correct, which is convenient because you should test migrations as well. It even supports Linux, which is really cool, and pretty much all the frameworks are supported, so SpriteKit, SceneKit, doesn't matter what you're doing, although I didn't actually have use case for testing SceneKit with snapshots yet. The other tool that I really like is Difference, which is something I built when I was building Sourcery. And the reason for that was because when you do standard equality checks in your complex objects, in your test suites, Xcode does this thing, which is basically print object A, print object B, and good luck to you to find what is actually wrong. So that's not very convenient, right? And when I do tests for something like Sourcery, which parses massive objects that have a lot of metadata, that's what I would get. That is absolutely not acceptable. That makes testing very hard, not very convenient. So I wrote Difference, which uses mirror, and when you do that, even if you have complex objects, what it actually says here, it tells you exact key and what value was expected, what value was received. So you can easily, when your test fails, just scan it, okay, this is wrong, and you go to the code and you fix it. So this is way more readable. The other alternative, which is newer, which is the logged, like custom dump, but point free, they took, I worked with them on a few things, but yeah, basically they changed what TCA did with their massive logs, because I also pointed out that that's not very convenient. So there's another version of the diffing. But either one you use is going to be much better than what Xcode offers. And what I recommend doing is just replacing xct assert equal, then all your tests suddenly have much better outputs. So that's very convenient. And the last thing I want to mention in terms of testing is page object pattern. I know how many people wrote UI tests before. So UI tests are very useful because they're testing real environment, real data most of the time. But most people write it in a way that's not very maintainable, because if you are gonna look into elements on screen in every test, first of all, that test is not very readable. And second of all, anytime you change your UI, you will have to go and modify multiple different tests, which is why people complain that testing is not valuable. Because if you make this choice, your tests are fragile. And the thing with TDD is, like, when you write new tests, you go red, green, refactor, right? So you first have a failing test, you make it pass the easiest possible way, and then you refactor the implementation detail so that it's nice, right? The thing here is, when you refactor, you should not be hitting red. Red should never happen. So when you create tests that are fragile and require you to change multiple test definitions just because you change implementation details, that is an anti-pattern. So you shouldn't do that. The simplest solution is using page object pattern. So if you Google for page object pattern, this is pretty well known in the industry. The idea is that for every screen that you have in your application, you create this higher level abstraction that defines, basically just describes what you want to do on that screen. So like I want to, here for example, I create an authentication screen, I type in my email, type in my password, press the login button, and then I expect to get a welcome message. This doesn't say how that screen looks. Right? I have no idea how it looks. Is it like no idea what elements are there? It's all hidden, which means that I can write 10 different tests for authentication screen, and then if the UI on the authentication screen changes, I just go and change that screen wrapper. So that makes my tests still keep green and just simply update the UI to match the newest designs. So that's much more maintainable way of doing testing. And there are three things I didn't really put into categories, which is Pulse. It's a powerful logging system that Darek actually showed me. It's really nice. It's one of the nicer looking open source UI that I've seen. Someone spent some time designing this. So this was created originally for networking, but it's actually a general purpose. You can log other stuff. Darek has an extension that logs TCA messages. It's also multi-platform, not Linux, but all the Apple platforms. So this is very convenient for standard logs that you have in your application. I highly recommend you try it out. If you want networking, I would recommend, rather than using Pulse, Pulse has also a premium app for Mac that you can run, but what I like is Proxyman. This is extremely powerful. So I used Charles in the past, but when I was researching my new video course, I was looking at Proxyman, and it's crazy how powerful it is. Not only does it have the standard stuff like, you can do SSL proxying, but you can do stuff like filtering. You can add debugging to your GraphQL request, so you can make a breakpoint, and if a specific thing in GraphQL is requested, you can change the logic. You can even use JavaScript to dynamically decide based on the params that the app gives you what you return. And you can also, because this is a man in the middle, right? So if people are not familiar, so my application, rather than hitting the server directly, I install specific profile, and it thinks it hits the server, but it hits Proxyman. Proxyman hits the server. So there's like a collaboration in between. So what it allows me to do is I can mock specific responses with local data. So I can have real data, but then I decide, well, actually this endpoint is going to be fake. So this is really cool for being able to test pretty much anything with the network. You can test bugs, you can test wrong responses. I love the idea that you can use JavaScript, as much as I don't like JavaScript. Being able to write logic dynamically without having to add if statements in my application, really powerful. And the last thing that I use in majority of my projects is SwiftUI introspect. So SwiftUI, it's very convenient. I love it. It's my default. The API is very lacking. There's a lot of things missing. Like, have you tried using video player in SwiftUI? I sometimes wonder how they create those interfaces, because it has almost no controls. You can pretty much not do anything, then put a video there that someone can press. That's not very convenient. That's not what AV Player exposes. So with SwiftUI introspect, what it does, it gives you modifiers that expose the underlying views. So the way SwiftUI works is you have those definitions of what you want to display on the screen. So I want text, I want video player. What the system does underneath, it actually creates UI label, it creates AV player controller, stuff like that. Introspect introspects the view hierarchy and finds the nearest sibling to your SwiftUI definition. So you can actually find the actual controller that's being used. And that allows you to tweak stuff that SwiftUI doesn't expose. So you can use view representable, but if you use view representable, you have to copy everything, right? You have to create your whole implementation. Whereas with introspect, you can just do small tweaks. And the new version of introspect added ability to specify iOS versions that they run on, which is very convenient because SwiftUI tends to change the implementations. So something that was implemented with table could be implemented with list or could be implemented with other collection view later on, right? So when you have this code, it actually says which version, and sometimes when you write this, you'll have another introspect for the older or the newer version of iOS. So this is also a very convenient thing to use. And I pretty much use it everywhere. I wonder if there's any project I didn't use it recently. Majority of projects I still use it. In summary, I would say, don't just stay with Apple defaults. Our community has created a ton of libraries. This is just the ones that I find useful regardless of the kind of product I'm building, regardless of the architecture. Pretty much every iOS application will have some networking, will need logging, will need beta settings. All those things are common ground. If you want to see the tons of different libraries, like there is this repo called Awesome iOS that lists hundreds of different contributions. And I write about this stuff. I create a lot of this stuff on my blog. So if you're interested in this, on the course I'm creating, you can subscribe at merowing.info. Here's my contact information, and I'm happy to take any questions.
With that view hierarchy traverser, do you notice any performance issues with, when you have view hierarchies that are getting bigger?
Well, it's only done when the view refreshes, so it's one off, right? Which also forces you sometimes, if you want to do some weird stuff like I did with Sourcery Pro, you have to hold on to that definition. So like I had a global, I had to, okay, this is my controller for the web views because I need something weird to be happening in real time. But it will only execute once, so like the performance shouldn't be an issue. Yeah. You had a question?
Do you suggest any non-standard build tools, any non-Xcode build tools, for example, Bazel for large industry projects? Or?
Yeah, so Bazel is very popular. I think Bazel is the most popular right now. I do not, so you have a couple of things, right? You could use Twist. Twist is the other very popular for smaller companies. What Twist does, it can generate your Xcode project. And that's convenient Bazel is way more powerful because Twist wouldn't optimize your build times. It wouldn't do any kind of weird caching. It's basically like a system where I define my project and it will define Xcode so I can run the standard tools. Whereas Bazel has a lot of power in terms of if I have large code base, like Airbnb, for example, uses Bazel. If I have large code base, I don't want to check out the whole code base because building that, it's just not possible in a finite time that I'm actually trying to get my work done today. So what it allows you to do is you can build parts of the project, similar how you have different modules, but it also does shared caching. So once a project has been built on the CI, it doesn't have to rebuild. It can actually grab just the artifacts. So Bazel is popular. I would not recommend using tools like Bazel to majority of projects because it is complicated. And unless you have someone that's actually responsible for maintaining your CI, custom configuration, stuff like that, it's just not worth the effort. For majority of applications don't need that scale support. But yeah, large applications, I think Bazel is the standard now. Mostly because of the caching. That's really powerful.
I just wanted to ask you if you think that using, for example, tools like Instabug is good for production?
So I tend to do custom UI for production. Like, for example, at the browser company, we just use Swift UI to do bug reporting for our users, fully branded. It uses Sentry underneath, but you could use Instabug. Like I like Instabug because it does a lot of things well and it's easy to use. And my general advice would be use the simplest solutions you can for as long as you can. Writing your own custom UI to do stuff like Instabug does with like the snapshots and stuff, that's not actually really straightforward. It took our engineer, like I'm working a music app right now, I think it took 2 days to write custom snapshotting because Instabug told us we'll not support Catalyst. No plans to support Catalyst. And we have Catalyst project. It's like, okay, then sayonara. Yeah, but you can use it. You definitely want to be able to give user ability to report that because it avoids the bad reviews. Like if you go to App Store on like some of the larger projects I have, people will give me 4 stars and they'll say, well, I'll give you 5th star if you fix this. So I want to avoid that. What I actually do is rather than asking user for review, I give them an option to also suggest an improvement. Because sometimes that happens, right? So they'll give me less stars because they want something fixed. If I give them the way to tell me what they want, I prevent them from giving me bad review. And then if I actually implement it, I actually get 5 stars. The other tool that I have in my video course is called Roadmap, which is also something Antoine worked on. And it's basically a project where you can expose the upcoming features and people can vote on it. So you predefine what kind of features you have on your roadmap, and the users can say, okay, I want this, I want this. And so that's very nice. The other thing that I would recommend is you can do a dynamic changelog, where whenever you do an update, you show the feature that you added. I saw one project doing that, and then people can react to that as well. And it's also like, if you have that, it's a very good way to ask for a review. So if someone liked a couple of your recent updates, you can ask them for a review because reviews, you can give a new review for every new version of the application. So that's like a perfect time to ask for, give me some 5 stars. Any other questions?
You said that you don't like JavaScript. Why?
I don't like mutability by default. I think it's easy to shoot your foot off. I don't dislike web technologies. I think they have place. I don't actually have a problem with hybrid either. Like I really enjoyed working with Flutter in the past. And I think I prefer TypeScript than JavaScript. That's my actually preference. Sourcery Pro, which is like a commercial extension to Sourcery, I actually wrote all the code editing in TypeScript because it was more efficient to learn TypeScript than to do it in Swift. Yeah.
Do you have actually any advice to manage a lot of modules when you're building them in a Swift PM application? Because it can become pretty complicated at some point, like just to switch project every time to define your different modules, then eventually push a version to GitHub, then come back to your main project because you fixed something. because at least from my knowledge, you cannot really change directly the module of Swift PM inside of Xcode.
Well, you can create schemes, right? So each scheme defines the target you want to run. So you can like depending on what you want to do, right? So if you want, do you mean like host it? So you want to run that? That's the preview apps, right? So if you have the preview apps, you have separate targets, and so you can decide, okay, I'm going to work on authorization, and that single file just defines the UI to boot up your module. So if you do that, that's actually the way to work on larger projects. Like that's what we did at the browser. I do it in a couple other companies as well. So that works pretty well. But this schema is the only Apple way of doing it. Toist is how some people do it, where they predefine some setup. But I really don't think you need Toist with SPM for majority of projects.